Hello, everyone. Today, we're talking about Terraform. So, why are we talking about Terraform? Well, as we all know, in 2024, ClickOps is not the way forward. Well, it's very simple to go to the Equinix Developer Console, deploy a new server. It doesn't give you confidence and repeatability that you can do that time and time again and get the exact same result. What we need to do is find a declarative way to create these machines. And Terraform is probably the industry standard for doing so. Terraform provides a declarative API using HCL, HashiCorp configuration language. And as you'll see in this quick demo, it's pretty easy to pick up. The documentation is great. And it's never been easier to create reproducible, repeatable environments on top of Equinix Metal. So when I say repeatable and reproducible, what exactly do I mean? Well, we don't just provision servers running a base operating system. That's not going to make you any money. Instead, you need to get your software or third-party software onto that server and configured the exact same way every single time. What you don't want is someone SSHing into a machine and running scripts or commands by hand, because that is going to succumb to human error. What we want is to have the machines do our bidding. That means we're going to use user data as much as possible, which will be executed for us when the machine is provisioned by Equinix Metal. By configuring this user data once, we then have the ability to scale our application across metros, or even take advantage of Equinix Metal spot pricing, which would rely on us to be able to spin up and down these services at a moment's notice. And this is really where Terraform shines. We get to define the infrastructure that we need, the machine type, and the user data, all in a single location, and have it automated for us. Should something go wrong, we can run the Terraform commands again, and our infrastructure will be replaced. And that's what we're going to show in today's session. Using Terraform with HCL to provision Nginx on an Equinix Metal server. So the first thing that we have to do is go to the Terraform registry. This is available at registry.terraform.io. And this is where you will find all providers available to consume with Terraform. To get started, search for Equinix. And we'll see the first one at the top, Equinix. We click on Use Provider, where we'll see an example of some Terraform HCL that we can copy. And if we head over to our editor, we can create a main.tf file, pasting in the code we copied from the registry. Now, before we do anything else, we're going to run a command on the terminal, notably Terraform init. This will scan the Terraform files that we have in this directory, identify the providers that we want to use, in this case, Equinix, and fetch them for us. So let's go back to the registry. And this time we're going to click on Overview. From here, we can scroll down to see an example of how to configure this provider with the authentication that we need to successfully provision servers and make other API requests to Equinix Metal. If we scroll down just a little, we'll see here that we can use an auth token parameter on the provider with an Equinix Metal token to make Equinix Metal requests. Another way to do this is just to ensure that the Metal auth token environment variable is available in your terminal, and that will handle the authentication for you. And that is the approach we're going to use today, just so I don't have to show you any of my tokens. Now, in order to test that our authentication works, let's create our first resource. On the left-hand side, you can see all of the resources available, and we're going to expand the Metal selection. From here, we can scroll down to Metal Project. Another way to find this would just be click on the filter box and search for the resource that you're looking for. We're going to copy this code to create a new project and paste that in to our main.tf file. Now, instead of calling this Terraform Fun, let's just call this Demo Project and save. So let's head over to the terminal. From here, we can run Terraform plan. This will show us that Terraform wants to create one new resource, notably the Equinix Metal project that we just dropped in the HTML for. We can then run Terraform apply. This will show us the same plan, and we can approve it if we're happy to proceed. And there we have it. A new project has been created. We can run Terraform plan. It refreshes our state and tells us everything is up to date. This is an ideal situation to be in. It means that our Terraform code is valid, our authentication works, and we can successfully provision declaratively resources on Equinix Metal. But we are not here just to provision a project. We want to get some metal. So here we are back on the registry documentations. And instead of searching for project, let's go for device. Select the resource that we want on the left and scroll down. With all the resources, you will always find an example which you're pretty much free to copy and edit to make your lives a little bit easier. If we scroll back up to the top of this page, you'll see that we can also select schema. This will show you all of the required properties that you need to set on your resource for Terraform to successfully plan or provision that resource, as well as all the optional properties which allow you to further configure and tweak the resource that you're going to provision. For us, what we are most concerned with today is the user data property on our server. This is what will be run for us at provision time to make our server do something beyond being a stock default operating system. So we go back to VS Code and we drop in the example that we copied. Because we're going to deploy Nginx, let's call this Nginx and make the host name Nginx 2. We can use the Ubuntu 20 operating system. We want an hourly billing cycle. And down here, we can set the project ID for this device. Now, we don't need to use a local variable in this case because we're using a resource that we are also provisioning alongside the server. You can reference resources by the resource type, its name, and the property. Of course, here we never changed the name of our project resource. So let's just call that project, updating a reference there too. Next, let's add our user data, which while we could begin to do this in line, it's not a very pleasant editing experience. Instead, what I like to do is to create userdata.sh. And this is a bash script where we get syntax highlighting because it's in its own file with its own extension, and your editor likely knows how to work with bash scripts. We can have this run an apt update and an apt install Nginx. Yes, like so. Now, instead of using our string here, instead we say that we want to load a file, notably userdata.sh. And probably your editor can format this document too. Now, to confirm that this is going to work, we can run Terraform plan. Now, because we changed the ID of our project, it's detected that it needs to destroy it and create a new one, as well as provision our metal device. So let's trust it. Terraform apply with a confirmation. Now, a device can take 1 to 3 minutes to spin up. So let's use some movie magic, and we'll see you all in just a second. And there we have it. Our Terraform device has now been created. You can start writing your Terraform code with everything that you've seen so far, layering on extra resources, learning how to work with Terraform modules, and keeping things refactored, clean, and dry. But if you want to get started a little bit faster than that, there are some fantastic resources from the Equinix Metal team. If you go to the Equinix deploy website, deploy.equinix.com/labs/Terraform, here you will find a whole bunch of examples of using Terraform to work with Equinix Metal. For instance, here's one of spinning up EKS Anywhere as a Terraform module, with a nice step-by-step guide and code, all available on the link at the GitHub page. This all lives on the Equinix Labs GitHub organization. to the point where you can just click on Equinix Labs, filter for Terraform, zoom in, and you'll see there are 36 different examples or modules that can be consumed today from Nutanix, Kubernetes, Equinix Metal Fabric, Network Edge, and many, many more. I hope you found this video useful. There is absolutely no reason not to be using Terraform to make your infrastructure declarative, repeatable, and reproducible. And that's a lie. There may be one reason not to use Terraform, and that is if you want to use OpenTofu. What is OpenTofu? Well, at present, it is a drop-in replacement for Terraform that is truly open source. You can consume Terraform modules with OpenTofu with no change to your existing HCL code. Thanks for joining us for this quick demo of using Terraform or OpenTofu to provision your Equinix Metal devices. Until next time.